ADHD is a mental disorder that can cause above normal levels of hyperactive and impulsive behaviors. People with ADHD may also have a hard time focusing on a single task or sitting still for long periods of time. This disease is one of the most common neurodevelopmental disorders diagnosed during childhood, and often 30% of cases follow children into adulthood. What if we were to tell you that this polarizing lack of focus and impulsiveness might be because of your genetic makeup and the environment you're in? The CDC states that in 2016, the number of children in the United States diagnosed with ADHD was 6.1 million, ages 4 to 17, which is about 9%. Furthermore, these children are more likely to be affected by debilitating disorders such as depression, autism spectrum disorder, and Tourette's syndrome, to name a few. ADHD is a highly heritable disease with almost 70 to 90% of the genetic variants in individuals stemming from genetic factors, while the other 10 to 30% is caused by unique environmental factors. While many different disorders can affect someone with ADHD, the one thing they all have in common is the expression of certain genes. A review by Samuel Cortese emphasized the importance of dopamine and dopamine transporter model systems in relation to ADHD. Today, we would like to examine these systems, which are affected by the COMT and SLC6A3 genes in correlation to ADHD. The COMT gene codes for the COMT enzyme, which breaks down dopamine in the brain's prefrontal cortex. Altered genotypes of this gene can lead to overproduction of dopamine in the brain, which can be responsible for ADHD and its symptoms such as inattention, maladaptive stress reduction, and impulsivity. The SLC6A3 gene is responsible for producing instructions to make a protein called the dopamine transporter, also known as DAT, which supplies dopamine to the brain. This protein is found in the membrane of neurons in the brain and is responsible for the pleasure and reward centers. When people have lower concentrations of dopamine in the brain, this can lead to higher symptoms of ADHD, which includes mood instability, impulsivity, and inattention. We intend to include the best 12 study genetic variations that affect ADHD on our SNP-Chip test. The two SNPs that we have chosen to identify for this dopamine response linked to ADHD are the RS4680 SNP, which is found in the COMT gene, and the RS27072 SNP, which is found in the SLC6A3 gene. The RS4680 is a single nucleotide polymorphism found in the COMT gene. Again, this gene influences dopamine breakdown in the brain, which is responsible for symptoms of ADHD. The possible genotypes for this SNP are being homozygous for the A allele, homozygous for the G allele, or heterozygous for one of each allele. Scientists have found that those homozygous for the A allele leads to 3 to 4 times reduction in the COMT activity, which increases dopamine and the likelihood of ADHD symptoms. Being homozygous for the G allele leads to 3 to 4 times increase in COMT activity, which causes an increase of dopamine, leading to symptoms of ADHD. The second SNP, RS27072, is found in the SLC6A3 gene, which again has an influence on the dopamine transporter protein. The possible genotypes for this SNP are being homozygous for the C allele, homozygous for the T allele, and heterozygous for one of each allele. Being homozygous for the C allele means a person may have 2 times greater risk for alcohol withdrawal symptoms and an increased risk in ADHD symptoms. Being homozygous for the T allele means you may have lower odds to exhibit ADHD symptoms, and being heterozygous for one of each allele means you perhaps have lower odds of showing ADHD symptoms.
The disease caused by SNP RS4680 is not very high risk, and people could go on living without even knowing they had it. Each different allele causes different personalities in a person, with the A allele being a warrior and a G allele being a warrior. Each of these traits only impact the personality of a person, so the risk behind the RS4680 SNP is almost none. The basic risk would almost be none, and the increased risk from having this SNP would be that you exhibit symptoms of ADHD in the form of worrying, or the opposite being that you don't worry but have lower cognitive abilities. The limitations to the RS27072 genetic test is not a whole lot is known about what this trait and alleles that cause it, other than it can cause alcohol withdrawal and increased chance of ADHD symptoms with certain alleles present. There is no high risk from this SNP, and a person would be just fine without getting the genetic test done. It would mainly come down to a personal decision to figure out the exact cause of someone's ADHD symptoms and whether or not they wanted to figure out what SNP caused it for them. The ethics of getting either genetic testing done would be, if diagnosed with this genetic disease, the outcome emotionally would most likely be one that is taken pretty easily. As mentioned, these SNPs are not high-risk diseases, and therefore hearing news of them shouldn't alarm anybody. The financial aspect of being diagnosed with this genetic disease is nothing too steep, and with insurance, the medicine given for it is no toll financially at all. Someone might not want to get tested due to the stigma behind ADHD of people not being able to pay attention or always off in a daydream. However, not getting tested could seriously cause someone to hurt mentally and emotionally, as the medicine they need for their disease could really help in focusing and staying on track. Getting tested would give a person the option to seek treatment through medicine and just having the knowledge of which disease they have. Other than that, there is nothing else that really comes from being tested, which is why a person should not worry about getting it done.